Good morning, my Algebra 2 students. Um, Today what we're going to do is, let's see, Miss Huffman is here with you, and she is playing this for you so that you can get this lesson on systems of applications. You all should have a worksheet out. Your homework tonight is page 144 in the textbook, number 55 to 58. So you want to get that done, and we'll check it tomorrow. Ms. Friedman, if you're willing to go around and check homework from last night, go ahead, you guys, and get out your homework from last night. All right. You can hit pause if you want. All right. So the lesson today is about systems of equations, and why would we use them? They actually have lots of applications, and this is actually really fun. So there are 4 steps that we want to make sure we take. A, we want to define our unknowns, x and y. Now it says x and y. I'm actually going to use some other variables because sometimes with word problems it makes more sense to be using different letters than x and y. So in this first problem, let's read it and then let's figure out what variables would make most sense. So a caterer is planning a party for 64 people. That sounds like a total to me. I'm going to underline that. The customer has $150 to spend. Looks like another total to me. A $39 pasta dish feeds 14 people, and $12 sandwich dish feeds 6 people. How many pasta dishes and how many sandwich trays should the caterer prepare? All right, so we're going to assume that each person only eats 1 serving of pasta or 1 sandwich. So right here in the question, it tells me about how to define my variables. When I define my variables, I want to say let. Now we need some letters. So we've got pasta dishes. We want to know how many pasta dishes and how many sandwich trays. So let's say P is our pasta dish variable. Let P represent how many. So is it the price of the pasta dish? Is it the number of pasta dishes we're purchasing? We want to know exactly what. So it's saying how many the caterer should prepare. So let P represent the number of pasta dishes the caterer should prepare. But I think I'll just write the number of pasta dishes. Okay, we can add the rest when we write our sentence. Okay, so P is our pasta dishes, and S is going to be let S represent, or we could just say B, that'd be faster. Let S be the number of sandwich trays. Okay, now that we have our variables established, we want to look for our totals. We want to write 2 equations that represent the 2 different ways that x and y are related. In our case, P and S are related. So I've got 2 totals. I can just set up my totals. I know that there are 64 total people that we need to feed. So I'm going to actually write people because it's going to help me organize my data. And then $150 to spend. So $150. So that's got my units as well. So we have a lot of information here. A $39 pasta dish. So my cost is going to go with my cost. $39 is what it costs. Oh, my pen ran out of ink. Okay, $39 is what it costs for each pasta dish. So if I buy 2, it's 2 times 39. If it's 3, I have 3 times 39. And I'd also have to spend $12 on every 39 on the pasta dish and $12 on the sandwich tray. So that's the equation that demonstrates the amount of money we're spending. Now, the $39 pasta dish will feed 14 people. So 14, this is our people equation. We're going to have people, people, people. So 14 people are fed with the pasta, and 6 people are fed with the sandwich tray. So now we have a system of equations. So this is our B. Now we can solve it any of the 3 ways that we talked about yesterday. And if you're still having trouble with some of those ways, there is that Prezi that takes you on all sorts of adventures through systems of equations um, by graphing, substitution, or elimination. So you definitely want to be looking at that um, either tonight or over the weekend, but tonight preferably. Okay, so, oh, let's say A, B. Oh, we need to do C, so let's solve it. I think I'm going to use elimination. So I see 12s and 6s, and I think, oh, I could make that into a negative 12s pretty simply. If I just multiply this whole equation, both sides of the equation, by a negative 2, so I'm going to do that, and I'm going to write it underneath here. So negative 2 times 14 is a negative 28p, and this would be negative 12s, and this would be negative 128, right? Oops, negative 128. So I multiply by negative 2 here, here, and here. Now I can combine those two equations. I can add these up, and that cancels out. That was my goal, to get rid of one of the variables. That, hence the word elimination. So 39 minus 28 would be 11p equals $22. I can divide both sides by p. Alright, so now we have 11p equals 22. Divide both sides by 11 and we get p equals 2. So we just figured out if p represents the number of pasta dishes to make, we now know that should be 2. So now we can write our solution in a sentence. We can say, let's turn the question around. How many pasta dishes and how many sandwich trays should the caterer prepare? The caterer should prepare prepare 2 pasta dishes. And what about sandwich trays? So we want to use one of our previous equations and say, okay, well, if we know that p is 2, plug p back in. 2 times 14 would be 28 plus 6s equals 64. I can subtract 28 and get 36, divide by 6, and s equals 6. Is that right? Yes. Okay. So the caterer should prepare 2 pasta dishes and 6 sandwich trays. There's a lot of work to show in that little amount of space. All right. So this is what has to happen in order for us to stay under budget and feed that many people. So we have these bounds right here. And if we looked at it graphically, we would see, if you could graph these two equations, you would see that this would be like an optimum value. All right, cool. So let's try the next one. All right, I'm going to give you a minute. I want you to figure out what your variables are going to be. Figure out your A, and then we'll check in. So let and let. Let's go ahead. So we're all using the same variables. Let's use N and D for nighttime and daytime. And I'll let you read the problem. Figure out what your N and D are going to be. Okay. All right, go ahead and hit pause. And then when you're ready, go ahead and hit play. All right. So it's very important that you say the number of. If you put the cost of nighttime minutes or the cost of daytime minutes, or just let N be nighttime minutes, it's not as clear as let N be the number of nighttime minutes, because we want to see how many minutes were used. So we want to go through and read this. Our family pays different rates for long distance calls made during the night and during the day. Daytime calls cost 12 cents per minute. Those are daytime minutes. And nighttime calls cost 7 cents per nighttime minute. Your family used that many minutes this month, so that is a total. So when I start my equations, I always want to keep a lookout for my totals. 425 minutes this month, and the total, there's another one, long distance bill was $36. So 425 minutes, and the other total was $36. All right. So how many daytime minutes did your family use? Well, oh, we're just asked for daytime, but we can find both. All right. Let's go ahead and write some equations. So we know the price is going to go with the price and the price. So go ahead and set up your equation. What do you feel is going to be your two equations, and then we'll check. So try it for a minute and see if you're correct or not. Go ahead and hit pause. Okay. So you should have gotten this. If you didn't, let's talk about why it is. So here we're talking about money, money, money. We want to make sure it's 0.07. We're talking about 7 cents and 12 cents. If you just said 7, that would represent $7. So be very careful that you have your decimal place where it needs to be. N plus D. This one wasn't as clear, but if there are a total of 425 minutes, you want to say, okay, well, what added up to 425? All my nighttime and all my daytime minutes added up to 425. So this almost was a simpler equation, but a little harder because it wasn't staring you in the face. Okay, now we're trying to isolate our daytime minutes. So how about we did the last one with elimination, let's use substitution for this one. So maybe I want to get my N isolated. I'm going to subtract D and solve for N. Right? So I just changed this equation so that I isolated my N. Now, in place of N, right here, I'm going to substitute in what N equals. So 0.07 times 425 minus D plus 0.12D. So this is my part B, my equation, and this is my part C, solving it. So we want to go ahead and do the math, and we find that oh my goodness. Okay, if I went too fast, you can pause and go back. I apologize. So my phone rang and I had to answer it, and then I just kept working. So let's go back a second. Undo. Undo. Okay. So I decided to use substitution, and I used this equation, plug that in for my N. So 0.07 times my N plus that. Distribute this here. Be careful it distributes. And add those two together. I got positive 0.05D. Subtracted 2975 from both sides. Divided by 0.05. And I get D is 125. In this case, it was only asking me how many daytime minutes. So I was like, okay, well, I'm done. I technically don't need to go back and find the nighttime minutes. But if I needed to, then I could say, okay, well, if daytime minutes was 125, I could then find nighttime minutes by plugging into this equation. Either equation would work. You could put it into either one of these, but I would always choose the simpler one because sometimes I'm lazy. All right. No, I'd rather make less mistakes, and I will probably make less mistakes in something like this as opposed to something like that. Okay. All right. So you've got, what, 4 more? 1, 2, 3, 4. All right. So I don't know that you guys need any more assistance. I think you probably are going to be aces at this. Let's just think about what each question is asking maybe and set up the variables, and then you guys get going. Okay? So what is the price each of one senior citizen ticket and one student ticket? So how could I write that? How could I write my lets? Let and let. So you have to decide variables. You could say X and Y because we like X and Y. We work with them a lot. Or you could say senior citizen and student both start with S. So maybe, oh, maybe you don't, maybe you just want X and Y. Let X equal, now in this case, is it the number of senior citizens tickets or is it the price? So you have to be really careful. What is the price? So let X equal the cost or the price of one senior citizen And then let y equal the cost of one student ticket. So, whoops, student ticket. All right. So I'm going to let you guys solve the rest. Here, it's telling us a situation. 4 senior citizens were sold. Oh, I'm not. Senior citizens weren't sold. You shouldn't sell senior citizens. 4 senior citizen tickets were sold, and 5 student tickets were sold, and the total was 102. So you can set up 2 different equations with those totals. All right. I want you guys to try it, and Miss Hoffman has, or I'm sorry, Huffman. Is it Huffman or Hoffman? I think it's Huffman. Oh, I'm sorry. Okay, but she'll have the answers for you so you can double check when you're done. All right, let's try the next one. What is the cost of an apple pie and the cost of a meringue pie? So make sure that you have the word cost or price in there. The school, oh, then we have more senior citizen tickets and child tickets. And my earphones just beeped, so I think that means I probably need to stop. Okay. All right. Thanks for watching. And do you want to finish this for homework? Oh, no, I'm sorry. I'd love for you to finish this in class. Your homework is page 144, number 55 to 58. Okay.